In the Arctic cold, the Soviet Union dropped Tsar Bomba, the largest nuclear explosion ever created. Built in secret and detonated with precision, it lit the sky brighter than the sun and shook the earth 3 times over. But how was it made? This is the story behind the Emperor of Bombs. The bomb race begins. In the eerie silence that followed the devastation of Hiroshima, Nagasaki, the world entered a new era, the nuclear age. It wasn't long before the terrifying power of atomic weapons became the centerpiece of Cold War rivalry. On one side, the United States had already shown its hand. On the other, the Soviet Union watched, waited, and then decided to strike back, not with war, but with fear. By the late 1950s, both superpowers were in a full-blown arms race, each desperate to prove their dominance. But for Soviet Premier Nikita Khrushchev, mere parity wasn't enough. He wanted something so powerful, so impossible to ignore, that it would stop the world in its tracks. He reportedly said, "Let this device hang as a sword of Damocles over the imperialists." And so the idea of Tsar Bomba was born, not just as a weapon, but as a statement, a message carved into the sky in fire and thunder. The mission? Build the largest nuclear bomb the world had ever seen. It wasn't about battlefield use, it was about sending shockwaves, literally and politically. This wasn't a casual decision. The USSR knew the risks, but to Khrushchev, fear was power, and Tsar Bomba would be his most powerful speech. Designing a monster behind locked doors in a remote Soviet lab known only as Artemis-16, a group of brilliant physicists was handed an impossible task. Create a bomb that could unleash more energy than all the explosives used in World War II combined. Leading this top-secret mission was Andrei Sakharov, a physicist whose name would later become synonymous with both genius and moral conflict. The design they settled on would be thermonuclear, using both fission and fusion in a 3-stage configuration. The goal? A staggering 100 megatons of explosive power. But the pressure wasn't just scientific, it was political. Khrushchev wanted results fast, corners were cut, and risks were taken. In this crucible of urgency, the engineers and scientists often disagreed, not just on the bomb's structure, but on whether it should exist at all. Some argued the ethics, others feared the fallout. But in the end, orders were orders. The team pushed ahead, balancing genius, fear, and duty as they inched closer to a bomb that could erase a city, or perhaps more. What started as a blueprint on paper was now becoming a real and terrifying object, pulsing with potential. The monster was growing, and there was no turning back. Anatomy of destruction. Imagine a steel cylinder the size of a city bus, weighing more than 27 tons. That's 5 elephants strapped together. That was Tsar Bomba. But what truly made it terrifying wasn't the size. It was what lay inside. At the heart of the device was a plutonium core encased in conventional explosives. When these explosives detonated, they compressed the plutonium to critical mass, triggering a violent fission reaction. But that was just the beginning. This initial blast created enough heat and radiation to ignite the second stage, a fusion core filled with lithium deuteride, a compound capable of withstanding extreme temperatures. Surrounding this fusion core was either uranium or lead, depending on whether more destruction or less fallout was desired. A layer of styrofoam, yes, styrofoam, played a critical role. It channeled X-rays from the initial explosion, heating the core and creating the pressure needed to kick off the fusion reaction. The result? A thermonuclear chain reaction that released unimaginable energy in just billionths of a second. It wasn't just a bomb, it was a sequence of precisely timed miracles, all designed to happen in less than a blink. One miscalculation, and it would have fizzled, or destroyed far more than intended. Why bigger isn't always better? While the original design aimed for 100 megatons, cooler heads in the Soviet program began to worry. A bomb that size wouldn't just devastate the test site, it could potentially throw radioactive debris into the stratosphere circling the globe. To avoid an environmental catastrophe, engineers made a key decision. They swapped out the uranium tamper, which would have caused extra nuclear reactions, with lead, drastically cutting down the fallout. This move lowered the yield to about 58 megatons. Still, 58 megatons was no small blast. It was over 3,000 times more powerful than the bomb dropped on Hiroshima, and And yet, this change turned a global hazard into a controlled demonstration. If such a thing is even possible at that scale, this adjustment was. Also a calculated political move. The Soviets wanted to show strength, not trigger global condemnation. By dialing it back, they delivered the message loud and clear without starting a nuclear winter. In the end, this wasn't a compromise of weakness. It was a chilling show of restraint, knowing they could have done more and chose not to. Tu-95's moment of terror. Transporting a bomb the size of a train car isn't exactly subtle. The Soviet Air Force had to modify a Tu-95V bomber, a long-range strategic plane, to carry the beast. Even then, Tsar Bomba wouldn't fit inside. It had to be mounted on the outside like a giant torpedo. To prepare for the blast, the aircraft was painted bright white to reflect the blinding flash. The crew knew they were part of a mission that had no room for error, and possibly no way out. Pilot Andrei Dernovtsev led the flight, knowing full well they might not survive. As the bomber approached the test site, a second observer plane flew nearby, loaded with sensors and cameras. At precisely the right altitude, Tsar Bomba was dropped, attached to a massive parachute designed to slow its fall. This delay gave the Tu-95 a small window, just enough time to escape the blast radius. But even then, they were gambling with their lives. If the parachute failed, if the bomb detonated too soon, the crew wouldn't live to tell the tale. Incredibly, they made it. But in that moment, flying away at maximum speed, the crew of the Tu-95 weren't just part of history. They were flying on the edge of human limits, with a bomb capable of ending everything. Countdown over Novaya Zemlya. The chosen stage for this unprecedented act of science and intimidation was Novaya Zemlya, a remote Arctic island chain cloaked in ice and mystery. Far from cities or villages, its isolation made it the perfect test range, but not far enough to avoid the shockwaves that would ripple across the world. On the morning of October 30th, 1961, two Soviet aircraft took off from a base on the Kola Peninsula. One was the Tu-95V bomber carrying the Tsar Bomba, and the other was an observer plane packed with instruments to monitor the explosion. They flew into cold, gray skies with everything riding on precise timing and technology. As the planes approached the test site, final checks were made. The bomb, already armed, was linked to a barometric sensor. This sensor would detect the change in air pressure as the bomb dropped and detonated at the optimal altitude, 4 kilometers above the ground. That height wasn't chosen at random. It was the sweet spot where the blast would be maximized, but the fireball wouldn't touch the ground, reducing fallout and radioactive dust. It was an eerie calm before the storm. Flying over snow-covered wastelands, the crew braced for what they knew would be the largest artificial explosion in human history. They had run the simulations. They knew the theory. But what was about to happen? No one had ever witnessed anything like it. Seconds ticked by. The bomb was released, descending slowly under a giant white parachute, giving the bomber just enough time to make its escape. The crew accelerated, flying away at full throttle. Then came the moment the world would never forget. 11:32 a.m. Moscow time. At 11:32 a.m. and the quiet over Novaya Zemlya was shattered forever. Tsar Bomba detonated in the sky with a flash so intense it could be seen over 1,000 kilometers away. For a fraction of a second, it was brighter than the sun. The Arctic sky turned to fire. Inside the bomb, 32 detonators had fired simultaneously, setting off high explosives that compressed the plutonium core into critical mass. This triggered a fission chain reaction, which in turn ignited the fusion fuel. Within 600 billionths of a second, the bomb completed a chain of explosions that released an estimated 58 million tons of TNT equivalent energy. The core temperature soared to 100 million degrees Celsius, hotter than the center of the sun. X-rays and gamma rays surged outward, instantly vaporizing everything within several kilometers. The physics behind the reaction were stunning. Radiation pressure created a plasma wave that compressed the lithium deuteride fuel, starting the fusion process. The resulting burst of neutrons caused more fission in the uranium, or lead casing, triggering a feedback loop of fission and fusion that spiraled into unimaginable power. The bomb didn't just explode, it erased the air, the snow, the very landscape. The world had never seen energy released on this scale. And still, the shockwave hadn't even hit the ground yet. The fireball and the flash. From the observer plane, what they saw was nearly incomprehensible. The fireball created by Tsar Bomba expanded to over 8 kilometers wide, so massive it nearly touched the bomber itself, even though the plane had already flown several dozen kilometers away. Within seconds, the fireball rose, climbing higher and higher into the sky. It pierced the stratosphere, soaring to an altitude of over 60 kilometers. That's 7 times the height of Mount Everest. The mushroom cloud it produced was not just big, it was otherworldly. Below, everything in a 35-kilometer radius was simply gone, vaporized or flattened. Wooden structures located over 55 kilometers away were reduced to rubble. And the heat? Reports later suggested that third-degree burns could occur at distances of up to 100 kilometers. What struck the scientific community just as much as the destruction was the sheer scale of light and radiation. The flash lit up the sky like a second sunrise, and its afterglow lingered even as the cloud began to spread. Windows shattered in Finland and Norway, hundreds of kilometers from the blast site. And then came the shockwave, a wave of compressed air powerful enough to circle the planet multiple times. The energy of this explosion was so vast, it briefly distorted the Earth's atmosphere. This wasn't just it was a declaration in fire, light, and sound. A weapon designed not to win a war, but to redefine the limits of what humans could build and destroy. Shockwave to oblivion. The energy unleashed by Tsar Bomba didn't end with the explosion. It rippled outward in all directions, carried by air, ground, and radiation. The shockwave was so intense, it broke windows nearly 900 kilometers away, rattling cities that had no idea what had happened. In military terms, the blast radius extended beyond what most countries could even imagine. The seismic wave generated by the explosion was picked up by instruments around the world. It was so powerful it circled the Earth 3 times, registering clearly on seismographs as far as New Zealand. Radio signals across the Soviet Union were disrupted. Even satellites recorded data anomalies. Everything from the ionosphere to the sea level trembled in response to that single detonation. But it wasn't just the numbers that told the story. Observers described trees snapped like matchsticks, wooden houses flattened as though by a god's hand, and an Arctic wilderness temporarily rearranged by invisible energy. No bomb before or since has ever come close. The sheer scale was so absurd that military analysts later admitted it was too big to be useful. A device like Tsar Bomba couldn't be deployed practically. It was too heavy, too slow to deliver, and too devastating to control. But it wasn't made for war. It was made for impact. An impact it had in physics, in politics, and in the minds of everyone who witnessed its consequences. A test, not a weapon. Despite everything, Tsar Bomba was never meant to be used in combat. It was a test, a carefully calculated performance meant to send a very clear message to the West. We can do this. The bomb's sheer size made it impractical. It couldn't be mass-produced. It couldn't be delivered in a typical wartime scenario. Its destructive power was so large that using it in an actual conflict would risk obliterating everything, including the attacker. This was political theater at the highest level, a performance choreographed with devastating precision. In the early 1960s, the Cold War was teetering on the edge of something far worse. The Cuban Missile Crisis loomed just a year away. Tensions were at an all-time high, and this test was like firing a warning shot straight across the globe. Tsar Bomba reshaped how the world viewed nuclear weapons. Even American scientists and military leaders were shocked by the scale of what the Soviets had achieved. It pushed both sides closer to the negotiation table. Not long after, treaties began to take form. The Partial Test Ban Treaty in 1963 was a direct result of weapons like Tsar Bomba. Agreements to limit tests to underground only, to prevent environmental damage and escalation. In the end, the bomb that was never dropped in war became one of the strongest arguments for peace. A tool of fear that, paradoxically, helped prevent the very destruction it was designed to unleash. Engineering the apocalypse. While Tsar Bomba's explosion captured the world's attention, the real story begins long before the blast, in the laboratories, bunkers, and design rooms where it was built. The weapon wasn't just a political tool, it was also an extreme exercise in precision engineering, where every second, material, and calculation had to align perfectly. At the center of this effort were Soviet physicists and engineers. many of them young, brilliant, and working under immense pressure. Leading the technical charge was Andrei Sakharov, a scientist whose theoretical genius laid the groundwork for what would become the largest man-made explosion in history. But it wasn't easy. The design pushed the boundaries of known physics. The challenge was timing. Every stage of the bomb, fission, fusion, secondary fission, had to happen in exact sequence, within fractions of a microsecond. If even one component was out of sync, the bomb would either fail or explode prematurely, with unpredictable results. To achieve this, Soviet engineers developed specialized detonators and shaped charges capable of initiating simultaneous shockwaves, technology that had never been tried at this scale. Then there were the materials: beryllium reflectors, lithium deuteride fuel, and even styrofoam. Each served a unique role in guiding radiation, compressing cores, or triggering reactions. These weren't everyday tools. These were chosen for their extreme properties, like their ability to withstand and conduct massive amounts of energy. The internal layout of the bomb was like a symphony of destruction. Fission provided the heat, radiation drove the fusion, and then additional fission released even more energy. This wasn't just a chain reaction. It was a carefully timed avalanche, rolling forward faster than light could travel across a room. And while the scientists understood the mechanics, many were deeply conflicted. Sakharov himself would later call Tsar Bomba the most terrible weapon ever created by mankind. It was a triumph of science, yes, but also a moment where genius crossed paths with devastation. In the lab, they weren't building a bomb. They were assembling the edge of human capability, teetering between innovation and annihilation. The world reacts. When news of the Tsar Bomba test spread, it didn't just shock military analysts, it shook the very foundations of global politics. Almost overnight, the bomb became a symbol of unchecked power, and the world began to take nuclear proliferation more seriously than ever before. In the West, intelligence agencies scrambled to gather data. The magnitude of the explosion caught even the United States by surprise. They knew the Soviets had advanced capabilities. But this was off the charts. Satellites picked up the blast, seismographs recorded the shockwaves, and analysts started recalculating what was possible and what might be coming next. Public reaction was swift and emotional. In Europe and North America, people protested in the streets, fearing that the Cold War had entered a dangerous new chapter. The concept of mutual assured destruction now had a horrifying new benchmark. Scientists, journalists, and political leaders began calling for restraint. Some even warned that the next test could push the atmosphere too far, or worse. Inside the USSR, state media carefully controlled the narrative. Tsar Bomba was framed as a triumph of Soviet science, a deterrent that ensured peace through strength. But not everyone believed the official line. Rumors of environmental damage and international backlash began to spread even behind the Iron Curtain. One of the most dramatic shifts, however, happened within the scientific community. Andrei Sakharov, once the mastermind behind the Soviet hydrogen bomb program, began to change his views. He saw firsthand what such power could do. In the years that followed, he transformed from a weapons developer into a vocal advocate for nuclear disarmament, and eventually a Nobel Peace Prize winner. The world had looked into the abyss, and it blinked. The test had proved a point, but it also made one thing terrifyingly clear. If this was the future, it had to be stopped before it started. Legacy of the Emperor Bomb. Today, Tsar Bomba stands not just as a technological marvel, but as a monument to human extremes. Our ability to create, destroy, and reflect on both. No nuclear device before or since has matched its raw, explosive power. And perhaps that's the most powerful message it left behind. In the immediate aftermath, Tsar Bomba influenced more than just military strategies. It shaped global treaties. Just 2 years after the test, the Partial Test Ban Treaty was signed, restricting nuclear tests to underground sites. The haunting images of that Arctic fireball were still fresh in the minds of diplomats and citizens alike. But beyond treaties and test bans, the bomb's true legacy lives in the story of its creators. Sakharov's turn from bomb maker to peace advocate echoed far beyond the Soviet Union. His warning that a thermonuclear war could lead to the extermination of mankind wasn't just theoretical, it was born from firsthand experience. Tsar Bomba also changed how nations viewed nuclear weapons. It became clear that bigger was not better. The strategic shift moved toward smaller, more tactical devices. Still destructive, but not civilization-ending. The world realized that weapons like Tsar Bomba didn't offer victory. They offered mutual annihilation. Even decades later, Tsar Bomba remains a point of fascination. Documentaries, books, and declassified files continue to draw new audiences into its story. It's both a warning and a wonder, proof of what humanity can build, and a plea that we never use such power again. In the end, Tsar Bomba was never used in war. It didn't flatten a city, it didn't end a conflict, but it left a scar on history. A towering cloud of fire that reminded us how close we can come to ending everything, and how vital it is to choose another path. Tsar Bomba was never meant for war. It was a warning. A blast so immense, it rewrote the rules of nuclear power. As science reached its peak, so did our need for restraint. Remember this: we built a bomb that could end the world, and then chose not to use it.